Okay, in this video I'm going to do, I think I can get through 6, 7, and 8 in this video as examples from homework number 1. And so on number 6, let me start there. Consider these two Boolean functions, P or Q and not P or Q. I had corrected this one in Angel, and this one was supposed to be P or not Q. It's supposed to be different. It's supposed to be just the opposite, basically. The minus sign is supposed to be on the other one for this one. So this is the corrected version as announced in class, and we want to use truth tables to determine which of these is equivalent to if P then Q. And this is going to be straightforward. I'm going to make a truth table with 4 rows for just 2 input variables, P and Q. I'm going to make my 4 rows here, and I'm going to do not P or Q. I'm going to do P or not Q, and I'm also going to do if P then Q. And we'll see which of these two is equivalent to if P then Q. Okay. P or not P or Q. So all we need is one of them to be true, and whenever Q is true, certainly it's true. And it's also true whenever not P is true, which is when P is a 0. But here we have a 0 because not P is false and Q is false, so they're both false, and so the OR is false. On the next one, the only time it's false is when both sides are, the only time an OR is false is when both sides are false, and that means P is a 0 and Q is a 1. P is a 0, Q is a 1 is this one. That's the only time that one's false. The rest of the time it's true. Now we move on to if P then Q, and if you'll remember, the only time if P then Q is false is if it makes a lie, meaning that if the premise is true but the conclusion is false, that's the only time it's false, and that's row 3 here. Rows 1 and 2, you can think of them yielding true as saying, well, the statement makes no claim if P is false, therefore we're going to define it as true here. And finally, if both the premise and the conclusion are true, then the if-then statement told the truth, and we have this. Therefore, the answer is that if P then Q is equivalent to either not P or Q, logically equivalent. And that sort of makes sense. I illustrated this in a previous example briefly, where we have a tautology, P or not P. We know that one of the either P or not P is true. But if P is true, then with the statement if P then Q, that gives us Q. And therefore, if P then Q is equivalent to either not P or Q. Okay? And so that's number 6. Hope that helps. And you know, I mean, technically I suppose we could remove the words if then from the English language and always just use or like this, but we don't do that, and if then is a very important part of what we do when we speak about things that we need to speak precisely about logically in English. Okay, I'll move on to number 7 here. And in number 7, I need to use a truth table to decide whether these two things are equal. And let's see, we have just P's and Q's here, so again, it's just a 4-row truth table. And so there they are, and I'll put those two over here, not P and Q or P. And I'll put not Q or P. And I will go ahead and do these step by step. First of all, I'm going to do a not P column here. Oh, it's saving. It takes a moment here. I'm going to do a not P column right here. Then I'm going to do a Q or P column right here. I'll put that one here. And finally, I'm going to take those two columns and AND them together, and I'll put that answer right here. So the not P is a 0011, so I have a 1100. And Q or P is only false when they're both false. Finally, I can AND these two columns here, and it's only true when both are true. And I can fill in the rest with zeros. And I can circle this and say that's the answer. Okay. Now I'm going to do the same thing sort of over here, where I'm going to make a not Q column. I'll go ahead and make a P column. Then I'll do the OR of those two columns, and then I'll negate that answer. Okay, so the not Q, the pattern on Q is 0101. So not Q is a 1010. The pattern on P is 0011. And then when I OR those, the only time it's false is when they're both false. And there's the OR. And now I'm simply going to negate that column. And I'll put that answer right underneath this negation. And when I negate that column, its pattern, that column's pattern is a 1011. And so I'm going to get a 0100. And here's my final answer. Okay? And in fact, they are equivalent. Is the answer. So they are equal. Okay? Finally, let's see, I think I have enough time for this one. I'm going to go ahead and do number 8 here. I'm going to make truth tables for both of these functions. And you know what? I'm going to make one great big truth table. They both have a P and a Q and an R. So this one now has 8 rows. I'm going to sketch that out quickly here. And I'm going to make both of these functions, P and Q. I'll do this quickly here because we're making a long video. Okay, there's part A. Here's part B. P and not Q. That thing or R. And, not P and not R. Wow. Okay, so first of all, I'm going to do a Q and R column. Then I'm going to negate it. Then I'm going to do a P and Q column. And I'm going to do an OR between the P and Q column and the negation of the Q and R column. And that's straightforward. P and Q is only true when they're both true, which is the last 2 rows. Sometimes I like to give myself the midpoint of this table. Q and R is only true when they're both true, and that happens on rows 4 and 8. So I make them ones. Now I negate this Q and R, and I get a 1, 1, 1, 0, 1, 1, 1, 0. And now I do an OR between these two columns, and an OR is only false when they're both false. Otherwise it's true. Okay, so here's my final answer. It happens to be false only in one case. That is when P is false, Q is true, and R is also true. Okay, quickly, I'm going to do the last one. P and not R. I'll copy P. And I'll make a not R column. 1, 0, 1, 0, 1, 0, 1, 0. I'll do an AND between these two. It's only true when they're both true. I'll negate that column. And it was a 1, 1, 1, 1, 0, 1, 0, 1. And I have to AND this column now with this whole thing on the left. P is 0, 0, 0, 0, 1, 1, 1, 1. Not Q is 1, 1, 0, 0, 1, 1, 0, 0. When I AND them, it's false unless they're both true. Okay. And now I'm going to do that or R. And R is 0, 1, 0, 1, 0, 1, 0, 1. And I'm going to do an OR of those two columns to go here. And an OR is true unless both of them are false. And now I'm looking at these two columns. And I'm ORing them. So all I need is one of them to be true. And finally, I'm going to AND this column I have to wait for it to save. Autosave takes a moment and knocks me out on the video. I'm going to do an AND of those two columns. And it's only true when they're both true. So I'm looking at these two columns now. And I'm doing an AND of them. I get a 1, a 1. This is a 1. Yeah, you see, that's why I'm circling this, because I think it's easy to make a mistake on this. And so here is my final column, 0, 1, 0, 1, 0, 1, 0, 1. Hey, that's equal to R. The whole thing reduces to R. Okay? Interesting. Okay, I'm done with this video.